Assalamu alaikum students. Today my topic is self-ionization of water, and this topic is from the chemistry book recommended for the 10th class, and this topic is also from the chapter number 10th of this book. Name of the chapter is acid, base and salt. So today we will discuss the self-ionization of water. Before knowing the self ionization of water, we should have the definition of self ionization of water. So, here is the definition of self ionization of water. Water will self ionize to a very small extent under normal condition. Direction in which this is the definition of self ionization of water. The reaction in which a water molecule donates one of its proton to a neighboring water molecule either in a pure water or in an aqueous solution. This is known as the self ionization of water. After writing the definition of self ionization of water, we should write the equation for the self ionization of water. So, here is the equation for the self ionization of water. As we know that self-ionization of water refers to the process where water ionizes into hydronium ion and hydroxide ion, so it can be represented by the following equation. See the equation, there is two water molecules, they react with each other and they are forming hydronium ion and OH negative. In this case, one water molecule behaves as an acid and other water molecule behaves as a base. So we are getting hydronium ion H3O positive plus OH negative. Before writing the relationship between Kw, that is the equilibrium constant, and self ionization of water, we should know that what is hydronium ion and what is hydroxide ion. The hydronium ion is a strong acid and hydroxide ion is a strong base. So they can associate, I am repeating, they can associate again to form water molecule. So in this case, they are again reacting with each other and forming water molecule. As a result, the water molecule and ion always stay in equilibrium. Yes, this is the line which we should underline this line so that water molecule and ions always stay in equilibrium. So at the equilibrium lies to the left. Thus, a very small amount of hydroxide ion and hydronium ions are formed in water. In this case, we should have a constant equilibrium, and this constant equilibrium can be represented by Kw. Thus, Kw must be equal to the molar concentration of H3O positive multiplied by molar concentration of OH negative. Simply, we can say that Kw means molar concentration of hydrogen ion and molar concentration of hydroxyl ion. So this is the self ionization of water and Kw. Kw is the equilibrium constant for the water. Kw is the equilibrium constant of the water. This is, we can say that hydronium ion is a very strong acid, hydroxide ion is a strong base. As a result of strong acid and base, they react to form again water. So at the equilibrium, we have ion, we have molecule. So in this case, a very small amount of hydroxide ions are found in water. So Kw must be constant and Kw must be constant. Kw can be represented molar concentration of H3O positive or OH negative. We can say that Kw can be represented molar concentration of hydrogen ion and OH negative ion. Here we can say that we can omit that the concentration of water molecule which should stay as denominator is the reason is not much change in the concentration is observed during this process. So the value of K is constant at particular temperature. That is the what is the particular temperature, that is the room temperature. The value of equilibrium constant of Kw is given, that is 1 into 10 raised from minus 4 multiplied by molar square and decimeter minus 6. This is the dependence of Kw must be dependent on the Increase with increase the temperature. Ionization of water is an endothermic reaction according to Lee-Chatterjee principle. If conditions are changed in equilibrium process, the equilibrium will shift to such a direction where it can minimize the effect of change of condition. Thus, if the water is heated, the equilibrium will shift to the right to form more ions by observing extra heat, as this is an endothermic reaction. Endo mean heat, observing reaction according to equation K. If the concentration of hydrogen ion increases, the Kw increase. So we can say that Kw depends upon the temperature. We can say that Kw depends upon the temperature. If we increase the temperature, then the Kw will be increasing. So now here we have the derivation. We can say that calculation of hydrogen ion and OH negative ion. To calculate the concentration of hydrogen ion and hydroxide ion, we can rewrite the equation as follow. We can rewrite the equation number 1 as follow. Molar concentration of hydrogen ion must be equal to the KWOH and OH, where KW is equal to molar concentration of hydrogen ion and pH of pure water. For pure water, the concentration of hydrogen ion and OH ion are same, so we can write this equation in this way. Hydrogen ion concentration of hydrogen ion must be equal to the concentration of OH negative. So from equation number 1 we can write Kw must be equal to hydrogen ion concentration square. Square means OH negative, so it could be equal to 1 into 10 raised from minus 14. For hydrogen ion concentration would square concentration would be equal to minus 14. So singular hydrogen ion concentration would be 1 into 10 raised to minus 7 moles per decimeter cube, where pH would be 1 minus log into 10 raised to minus 7. So the pH would be 7. This is the neutral pH. So we can say that the pH of pure water is 7. The concentration of hydrogen ion and OH ion must be equal. So the student, this is the calculation of hydrogen ion and OH ion. This is basically the derivation of self-ionization of water, where the molar concentration of hydrogen ion and OH ion must be equal. That's why we are considering water as a neutral. So this is the main calculation of our topic, that is the self-ionization of water. Then there is acid, basic, and neutral solutions relationship. Acid, basic, and neutral solution. In pure water, the concentration of hydrogen, hydronium ion, and hydroxide ion are same. That is equal to 10 raised by minus 7 at 25 degrees centigrade. This type of solution is known as the neutral. But depending on the difference between their concentration, the solution is named as acid, base, and salt. If concentration of hydrogen ion and OH ion is equal, then the solution is neutral. If hydrogen ion concentration is greater than OH ion, then the solution is acidic. And if the concentration of hydrogen ion is lesser than OH negative, then the solution is basic. And this is known as the acid, basic, and neutral solution. Thank you, student. If you have any question, do ask me at my email address that is given. So if you have any question, do ask me here. Thank you.